In this problem, we are given the following circuit diagram. We need to find the value R, which is right here, that enables the circuit to deliver maximum power to the terminals A and B. After we find this, then we need to find the maximum power. To start this off, we are going to find the voltage. We're going to look at this as a theorem equivalent circuit. That's how we work with maximum power transfer, and this can be found in section 4.12 of the notes linked in the description. And normally when we find Thévenin equivalent circuits, we use the node voltage method, which is exactly what we are going to do here. Once we find the voltage and then use the mesh current method to find the current, we can get the resistance and then use all of this to calculate the power. We're going to look at this first equation that I drew, and since we need to find the voltage, we are going to be doing this in two steps. We're doing the voltage up here, and then we are doing the current down here. Looking at this first diagram, we are going to get our nodes. This is a node, and this right here is a node. So we have node 1, and we have node 2. We have our 100 volts going into the positive out of the negative this way, and then our 20 volts going into the positive out of the negative this way. We also have our V0, which is going into the positive out of the negative this way, and this other V0 up here, which is going into the positive and out of the negative that way. Now that that's all set, we can start writing things out. From section 4.2, we can look at our node voltage method, and we know that we have the V1 minus the source current. In this case, it's going to be V1 minus 100 volts, and this is all over the 4 ohm resistor. This is this part right here. Next, we're going to deal with the current, and that is going this way. So we notice over here, we have our V0, and then we have this 20 volt resistor. Well, we know that our voltage for V2 is going to look like this, and then we're going to have the same thing for our V1. However, our V1 is the voltage across this entire piece. So when we do this, we are going to have a plus, and we can actually write this out down here. V1 is equal to V0 plus 20 volts. We don't know V0, so what we're going to do is say V1 minus 20 volts is equal to V0, and then just put this right here. This is V1 minus 20 volts, and because this is the same thing as this statement right here, we just won't have a V0. Instead of that, we'll have a V1 so that we can combine the V1s. And this is all happening over this 4 ohm resistor right here. So this is over 4 ohms of resistance. And next we're going to have our plus V1 minus V2 with the resistor that it's over. So we know that we have this entire V1 minus V2, and it's happening over this 4 ohm resistor right here. And that's all the parts leading into this node. So we are going to set this equal to 0. We'll simplify this a little bit by multiplying everything by 4 ohms and then combining like terms. After we do that, we are going to get this as our equation. 3V1 minus V2 is equal to 120 volts. Now we're going to look at the second node. So in doing this, we know that we have some voltage coming across this way. And when we write that, we know that it's going to be V2 minus V1, and this is all happening over that same 4 ohm resistor, plus there's nothing for our V2 area. So what we're going to look at now is the voltage flowing from the upward direction. We know that our voltage is flowing to the left, so we can draw it like this, and we can see that this is going to connect with this 100 volts down here. So what we're going to have is our V2, like normal, minus, and then since our 100 volts and our V0 are in connection, V0 plus 100 volts. And this is all happening over this 4 ohm resistor right here. And this will all be set equal to 0. So far, we have 3 unknowns, but only 2 equations. So after we simplify the second equation, we're going to have to solve for the next one. And this is going to be our second equation. So now we can look at our third equation, which we need to find the V0 for. And we know that our V1 is equal to V0 plus 20 volts. We actually found that down here. Since we already have an equation for our V0, all we need to do is rewrite this to make it match the other ones. So we know that we need a V1. We're going to move everything except for the 20 volts over to the left side so we can get only a constant on the right. We're going to have a 1 V1. We don't have a V2, so we're going to do plus 0 V2. This will help when we plug it into a matrix calculator. Minus 1 V0 is equal to 20 volts. So this is what we would be plugging into our matrix calculator. Checking the first equation, we should add a V0 just so we can make sure that when we plug it into a calculator, it's going to be correct. So in our first part, we will have a plus 0 V0, and that's equal to 120. If we do this, we're going to get the values 80, 120, and 60. Before I plug these into our matrix calculator, I represented V1 as X, V2 as Y, and our V0 as Z. I'm just going to correct this down here because I had a V3 and not a V0. So those are going to be our answers. And we know that our V2 is located right here. And if we look at the Thévenin equivalent, this is where we want our voltage to be. So this right here is going to be our voltage. That means our V2 is equal to our VT of H. So this is the VT of H that we need. Now we just need to find the current flowing through here, and then we can use Ohm's law to find resistance. Looking at the second picture, we are now going to find the current flowing through here. So we know that using the mesh current method, we can draw the direction of a current. I'm going to draw it going around like this. And so those are our currents. This is going to be our I1, this will be our I2, and this will be our I3. And we're going to solve for each of them respectively. First, we are going to label which way our voltages are going again. We know this one's into the positive, out of the negative, so is this one, and so is this one, and so is our V0, all into the positive, out of the negative. So when we look at our I1, we're going to solve for I1 first. We know that our 100 is going in the opposite direction of our I1, so we will have a negative 100 volts, plus now we're going to calculate the resistors in I1. So we can see that right here, this 4 ohm resistor is with our V0. Well, since we're going to use our V0, we are not going to use the 4 ohm resistor. We're not using this. So we're just going to have a plus 4 ohms I1. Now we have this 4 ohms also next to our I3, which is an opposite direction. So we're going to have a minus 4 ohms, and this is for our I3. Lastly, we have a 20 volts in here. This is going in the same direction as our current, so we're going to have a plus 20 volts, and this is all equal to 0. I did forget something though. Before we put this 0, I mentioned it. I forgot about this V0 right here. Well, the V0 is also going in the same direction like our 20 volts, so we are going to also have a plus V0, and then this is all equal to 0. I'm going to simplify this. I'm going to move around some things and just divide everything by ohms. That way we only get amps. So I'm going to have 4I1 minus 4I3, and then the constants I'm going to move over to the other side. So I'm going to have 80 amps and then a plus V0. And again, this is equal to 80 amps. Now I'm going to focus on the second current. We can see the only resistor in here is this 4 ohms right here. So we are going to have a plus 4 ohms for our I2. We're not going to have anything for our I1, so we should just put a 0 ohms of I1, and this will be plus our second resistance. Now we know that our 4 ohms I2 is next to our I3, which is going opposite direction. So we are going to have a minus 4 ohms I3. We have this 20 volts of voltage. It's going in the opposite direction of our I2. So we're going to have a minus 20 volts. When we look over this, there's nothing else we can do. This A and B should actually be closed like this, so we're not going to worry about anything else after that. However, lastly, we do have our V0 right here, and it's going again in the opposite direction of our current, so we will have a minus V0. Now everything looks like to be taken care of, and we are going to move some things around. That is our second equation. So far, we now know that we have 4 unknowns, so we're going to have 4 equations. Looking at our next equation, it's going to be our I3. So in doing this, we know that we have 4 ohms against our I1, so we'll start this off with a negative 4 ohms of I1. We have 4 ohms against our I2, so we're going to have a negative 4 ohms of I2. Now we can look at our I3, which is the current, and this is 4 times 3 because there's 3 4 ohm resistors, so we will have a 12 ohms of I3. Lastly, we have a V0 going into here. It is going in the opposite direction of our current, so we will have a minus V0, and that's equal to 0. It's important to note that after each of our V0s, we have an amps instead of voltage. For our V0, when we look at it, we can see that it's going to be over the 4 ohm resistor. So now we are actually going to be using this 4 ohm resistor. So we can say that our V0, and we know the formula for resistance. We know that for voltage, we know that voltage is equal to current times resistance. So this is what we need. Our V0 is equal to the current. So our I1 is going in the direction of our voltage, so we have I1. The I2 is going in the opposite direction, so we have a minus I2. This is being multiplied by the resistance, which is the 4 ohms highlighted in pink. Now we need to write this as an equation. So we are going to move everything from the right to the left. We are going to have a negative 4i1 plus 4i2. We don't have an i3, so we'll do plus 0i3. And then we have a plus v0, and that's all equal to 0. So this is our fourth equation, and these are all of the things that we are going to be plugging into our matrix. Plugging all this into a matrix calculator, we will get this as our answer. When I made the calculator, I said that our A is equal to I1, and we know that A is equal to 45. And then we said that B is equal to I2, and we know B is equal to 40 in the calculator. And C is equal to 30 ohms, which is I3. And I'm sorry, not ohms, but amps. These are all amps, by the way. These are all measured in amps because they're all currents. And then D, lastly, is going to be our V0, which we said is amps right here because of how we divided out the ohms. And this is going to be equal to 20 amps. So these are all our currents, but we only need one, an important one. And this current is going to be our I2 because we can see that it's going to be in the same area as our resistance right here. We only need this current. So we're only going to be looking at this current right here. Now we know our current and we know our voltage. So now we can use Ohm's law, which we know is that resistance is equal to voltage over current, and say that our voltage is 120 and our current is 40. If we divide both of these, we're going to get that our resistance is 3 ohms. So that is the answer for our first part. Now we need to find power. So looking at the notes linked below, section 4.12, maximum power transfer, we know the formula for power is that P is equal to the voltage, T of H, squared divided by 4 times RL. Well, we know what our voltage is. Our voltage is 120, so we'll have 120 squared. And this is going to be divided by 4 times our resistance, which is 12. We know this to be 1,200, so that means that our power is equal to 1,200 watts. This is the answer for this problem.